Hello, welcome to a new chapter. We are going to um, talk about triangles in this chapter, and before we can really get into it, we have to make sure we have some definitions down. So this very first slide is an important one. I want to make sure you get this down, write down everything, draw the pictures, do the best you can with it. I'm going to add some things to these pictures here in a moment, so I want to make sure you can first get the outline. So we're going to classify triangles. So when I say these names, you'll have an idea what I'm talking about. So let's start off with the first one. It's called scalene. And here's what it means. All the sides are different. So the way we can mark that, the quick way we could do something like 1, we could do like 2, 3, basically showing that these are all different. And what's interesting about triangles, we're going to learn that sides and angles have a relationship. So if 3 sides are different, guess what? 3 angles are different. So I'm not going to mark the angles. It'll be a little too busy, but make sure you understand that, you have all sides different, all angles different. Okay, so we've got two, all the sides are different, but what about isosceles? That's where you have 2 sides that are the same. So let me put these 2 tick marks. These are single tick marks because these are the same. Now, what's cool about that, just like up here, if all sides are different, all angles are different. If you have 2 sides the same, you have 2 angles the same. And we even know in a triangle where they are. And I put little dots just to give you a little clue. What I like to do with isosceles, one of the little tricks I like to do, I'll put a little arrowhead on the end of this, and it kind of points, not perfectly, but you can kind of see how it points to the angles that are the same. So I'll repeat that. If you have an isosceles triangle where you have 2 sides the same, follow the little tick marks, and that'll point to the angles that are the same. So those 2 angles are the same if those 2 sides are the same. We call that isosceles. And then we've got one where all the sides are the same and all the angles are the same. So that's pretty cool. That's called an equilateral triangle. And I'll say it again, all sides are the same. So that would be 3 single tick marks. And I don't need to point to anything because if all my sides are the same, then all my angles have to also be the same size. And then this is a quick one. It's simply a right triangle, we say, and it just simply means it has one right angle, if you ever hear right triangle. So we've got scalene, everything's different. Isosceles, 2 sides the same, 2 angles the same. Equilateral, everything's basically all the same. Okay, with that knowledge, we are going to jump into our first rule of the isosceles triangle. Very important slide here. Make sure you get this down. The base angles of an isosceles triangle are congruent. So what are the base angles? Well, these are the base angles. And I have pictures here, so you can kind of read and follow the arrows. But these are the base angles. These are the congruent sides. So if these are the base angles, then this is the vertex angle. It's the one that's different, basically. But remember what isosceles triangles have. 2 sides the same. And I kind of remember said, make it a little arrowhead. It's a little trick. Kind of points to the 2 angles that are the same. All right, let's get some more rules. So first we have some rules. We have a little practice today, but a lot of rules today. A line of symmetry, folks. I'm sure you've heard of symmetry before. It's kind of when you can fold something in half and it's an exact match. So we would say something is symmetrical. I think of a butterfly. It's always what I think of. Their wings, they basically can fold right on each other and they're perfect matches. Pretty cool. So a line of symmetry for an isosceles triangle. So it's nice and slow. The line that cuts in half the isosceles triangle bisects. That means cuts into 2 equal pieces. The vertex angle, now let's just stop there. That's this right here. So we can get all of our stuff. We just learned all this new terminology. So a line of symmetry will cut this thing in half. So I'm going to put a little mark and put a little single tick mark on each side. Basically, this angle here and this angle here are congruent. It's also perpendicular. That means forms a right angle, which we have, but it also says bisector of the base. So this is the base. It cuts that in half too. So when you have a line of symmetry, essentially, you've made 2 twin triangles. If you take a look, you can fold, one triangle right on top of the other. So basically, this angle gets cut in half. This is always a right angle, and this bottom base also gets cut in half. So these are just some rules that we can apply when we see isosceles triangles with lines of symmetry. All right. Now, if we have two angles that are congruent, then the sides opposite are also congruent. This is a lot like this right here. This we start with two sides of the same, then we know two angles are the same. But now we're saying we have two angles the same to start with. So what'll happen is, then I have two sides that are the same. It's just basically the opposite. But, it's the same ideas. You have this figure that looks like this. You got your two sides the same, two angles the same. Or in this picture, once again, we have two angles the same. So the sides that are opposite. See, this side is opposite this angle here. The sides opposite are also congruent. So two angles the same, two sides the same. We just lock that in. All right, let's play now. We learned some rules, a lot of new terminology, but let's slow down here and get a good set of notes. It says that EC is a line of symmetry for an isosceles triangle. Now, that's something we just talked about with that last two theorems ago. It was this theorem right here. So some things are going to happen. It's going to cut this triangle perfectly in half. All right, they give us a given. Angle MCJ is 72. I need to fill that in always when I read that. So MCJ, that's this entire angle here. So the way I kind of do that, it's hard to, I'll put it right in the middle. That's 72 degrees. Find the measure of angle 1. So if you see right here, angle 1 it's basically going to be half of this. Because remember, if this is a line that cuts the whole thing in half, then it's obviously going to cut the 72 in half. So we'll do 72. I'll use my calculator just for speed, divided by 2. We should get 36, and we do. So if you can't fit it in there, you can do arrows. I'm going to put a little arrow, 36 degrees. But also, this other one's 36, so maybe I want to fill that in too, even though I didn't ask for it. So I got angle 1 is 36. They want the measure of angle CEM. Let's find that one. CEM, that's this angle right here. Now, if you remember, this is all directly from this. It forms a right angle, doesn't it? That fold line, we'll call it, that's line of symmetry. So this is 90 degrees. I'm going to fill this underneath. So this one's 36. This one's 90. And then they want to know EJ. This is not an angle. As you can see, it doesn't have an angle symbol. This is how big EJ is. How long is it from here to here is what they're asking. Well, if it's an exact match of the other side, this says 3, doesn't it? So then guess what? EJ will also be 3. Not degrees, because we're not doing angles. So that is, once again, when you cut an isosceles in half, you get a mirror image on each side. Pretty easy, pretty cool once you get the hang of it. Okay, let's talk more about equilaterals now. If you have all sides the same, you have all angles the same, something we talked about in that first slide. So we have a name for that, though. If it's all sides are the same, it's equilateral. And if it's all angles the same, it's equiangular. So can we say that if a triangle is equilateral, that it's also equiangular? Yes, it's exactly what this is saying. And that's all. It's just a quick note. Basically, if all sides are the same, then all angles will be the same. I'm going to skip this theorem, guys. It's not worth our time this year. A little bit of a tricky problem here. Which angles must be congruent, we're asking. And I'm looking for some clues. I see an isosceles triangle right here. So let's go back to thinking about the vertex angle, the base angles, all that stuff. Two sides that are the same, find your base angles. That means the ones that are opposite these sides. Remember I showed you, follow the arrows, make your little arrows like that. All right, so if I do that, that means angle 1 and angle 3 are the same size. And that's it. So angle 1 and angle 3, that's all. Some students try to get in this triangle, but there's no clues that can really get us anything over there. We don't know enough information to say anything about this triangle. So it's really kind of there just to trick you. All right, and our last one here for notes. This is a bigger problem, but this is going to cover a lot of stuff. So make sure you get a good copy of it. Hit the pause button so you don't miss out on how I'm doing all this. But let's start with our clues. Triangle ABC is an equilateral triangle. Okay, we need to think about what that means. As soon as I hear equilateral, I know all these sides are congruent. I can't really mark this last side because I guess I'll put it right there. And it says that CD cuts the thing right in half. Well, those are some good clues to have here, so we can definitely work with that. Let's start with what they're asking here. The measure of angle BDC. Let's find BDC. Okay, So if this is cutting the thing right in half, this would have to be a right angle. That's back on that one theorem we discussed. All right, let's go right below. How about angle ACB? So they want this entire angle here. All right, now, I don't know if you caught it, but when we're talking about equilateral triangles, look at the angle measures. They have to be 60 degrees every time. You don't even have to do any math. So if this is equilateral, which it says it is, all the angles are 60. So I can fill in 60 here, and I can fill in 60 here right away. So this is equal to 60. Now they want the measure of angle 2. So you got to think about this. Well, isn't this cutting it right in half? Sure is. How do I know that? Because it tells me right here that this is a line of symmetry. So if that's 60, we cut that in half to get 30 degrees. So I'll put it in the figure and in my answer space. Okay, how about, now this is not an angle. Once again, this is a side, BC. Where are you, BC? You're right here. How big is this side? Well, if it's equilateral, they're all the same size. And we have a clue right here. If that's 6 centimeters, then this is also 6 centimeters because it's equilateral. Okay, let's jump to the other side here. The measurement of angle CAD, which we already did because it's equilateral, all the angles are 60. Measurement of angle 1, well, if that's 60 and it's cut in half, we already kind of discussed that. That's also 30, just like angle 2 was. So that one's 30 and 30. Okay, we're really getting everything here. How big would this side A be? That would be 6 centimeters also, because the other sides were also 6 and all the sides are the same. And then how would I figure out how far it is from A to D? Well, if the entire thing AB is 6, it's only going to be half of it, 3 centimeters. So it's really just thinking about folding things in half when you talk about lines of symmetry. It's important that you study your vocab on this one, what a scalene, isosceles, and equilateral is. Remember, no sides the same, no angles the same. 2 sides the same, 2 angles the same. 3 sides the same, which is what we have here, 3 angles the same. They're all going to be 60s. So those are the big notes in this section. Hopefully you get a good chance to pause those vocabulary slides and make sure you understand it before you move on. That's it for today.